Alright, this is your electrostatics worksheet. So let's look at example A. When sugar is poured from the box into the sugar bowl, the rubbing of sugar grains creates a static electric charge that repels the grains and causes sugar to go flying out in all directions. If each of 2 sugar grains acquires a charge of 3 times 10 to the negative 11 coulombs at a separation of 8 times 10 to the negative 5 meters, with what force will they repel each other? Alright, here's your formula. Force is equal to K times the charge of object 1 times the charge of object 2 over the distance between the objects squared. So this one's pretty easy. You just plug into the equation. The variable K is 9 times 10 to the 9 Newton meters squared over Coulomb squared. And I called it a variable, but it's actually a constant. It's the proportionality constant, and it was in your notes yesterday. For these sugar grains, the charge is the same on each one of them. So I'm just going to put the charge in once. Q is the charge. And the charge is 3 times 10 to the negative 11 coulombs. Since it's the same value, we'll just square it. And the distance between the 2 sugar grains is 8 times 10 to the negative 5 meters. And that also needs to be squared. So Monday, I'm not going to be here. The sub will be here, and after the sub will give you time to study for your quizzes. Then you'll take your quizzes, and then after you've taken both your quizzes, you'll work on this worksheet. I'll leave calculators out for you, and what you want to do on Monday is practice plugging this into the calculator. The answer you should get when you put this into the calculator is 1.3 times 10 to the negative 3 newtons. And you're going to want to be careful when you're putting this into the calculator. Be careful to square that distance. That's what students seem to leave out most of the time, squaring the distance. For these units, notice meters down here will be squared. So this meter squared will cancel with this meter, and then this coulomb will be squared, so it'll cancel with coulomb squared. And then the unit that you're left with is the newton, so that's what we put on our answer. And newton is the unit for force. Jalen, what's your question?
You answered it. I was going to ask you what was under and squared.
Okay. So that's example A. Example B, Bonnie is dusting the house and raises a cloud of dust particles as she wipes across the table. If 4 times 10 to the negative 14 coulomb pieces of dust exert an electrostatic force of 2 times 10 to the negative 12 newtons on each other, how far apart are the dust particles? Yep, that's right. We're solving for distance. So we'll write the equation. Force is equal to K Q1 Q2 over d squared. And what's our first step in solving for distance? That's right. We've got to multiply by distance squared. You cannot solve for something that's in the denominator. You have to get it out of the denominator. So if you multiply it, you put it in the numerator over on the other side of the equation. Cancel out distance squared. And I'm going to rewrite the equation. Distance squared times F is equal to K Q1 Q2. Divide out F. Whatever you do to one side, you have to do to the other. So divide out F over here. Get rid of F on the left. Rewrite the equation. D squared is equal to K Q1, Q2 over F. What now? Take the square root of D. Good. Whatever we do to one side, we have to do the other. Take the square root of the whole fraction. So D is given by the square root of K Q1 Q2 over F. So I'm going to first put in a big square root sign, and then I'm going to put in my fraction line, and then I'm going to plug in the variables. So you always solve for your variable before you plug in the numbers to the variables. K is our proportionality constant, 9 times 10 to the 9 Newton meter squared over Coulomb squared. Again, the charge on the pieces of dust is the same value, so we can just plug it in once and then square it. Instead of multiplying Q1 times Q2, we'll just put in Q and square it. 4 times 10 to the negative 14 coulombs squared. And then the force is 2 times 10 to the negative 12 newtons. Let's get rid of these units. What cancels? Newtons cancels. And Coulomb squared will cancel with this Coulomb. Be sure you don't cancel out the square here because you still need to square that number. If you cancel it out, then you're going to forget to square it, possibly. When you plug this into the calculator, you should get 2.7 times 10 to the negative 3. Alright, we have meters squared, but the last operation you're going to do is take the square root. So the square root of meter squared is meters. Your calculator on Monday may give it to 0.0027 meters. It's the same number. This is just in scientific notation. So you're going to make sure, you're going to verify that you can get the right answer on this on Monday, on these example problems before you actually do the practice problems. Alright, last example. An electron in Tammy's TV is accelerated toward the screen at a potential difference of 22,000 volts. How much kinetic energy, measured in joules, does the electron lose when it strikes the TV screen? Yesterday I gave you a formula, and I said that the electrical potential energy, also known as voltage, is given by the work, or force times distance, per charge. Alright, are we given voltage? Yes, 22,000 volts. Are we given work? No. We need to solve for work. Work is the same thing as kinetic energy. It is measured in joules. Are we given charge? Nope. I have to give you charge. So the charge of an electron is this. 1.6 times 10 to the negative 19 coulombs. That's how much charge each electron has. And remember, all electrons have the same charge. Okay. What are we looking for? Work. So we need to rearrange our formula. We need to solve for work. How do we solve for work? That's right. We multiply each side by charge to get rid of charge down here in the denominator. Okay. Cancel out charge, and work will, or kinetic energy, will be given by voltage times the charge. So voltage is 22,000 volts. And charge is 1.6 times 10 to the negative 19 coulombs. Multiply those together and you should get 3.5 times 10 to the negative 15 joules. Turn your paper over. Number 1 is just like example A. Number 2 is just like example B. Number 3 is just like example C. And number 4 is like example A, but you need to convert centimeters to meters. Alright, this is due Tuesday after spring break, and you'll have some class time on Monday to work on it.